Space radiation on Earth. We are shielded by the planet's magnetic field and atmosphere from the majority of particles that make up the space radiation environment. Even so, everyone on Earth is exposed to low levels of radiation every day, from the food we eat to the air we breathe. In space, astronauts are exposed to varied and increased levels of radiation that are different from those on Earth. Three major sources contribute to the space radiation environment: particles trapped in Earth's magnetic field, solar energetic particles from the sun, and galactic cosmic rays. A big challenge in reducing the risks of radiation exposure is that some space radiation particles, especially galactic cosmic rays, are difficult to shield against. Exposure to increased radiation can be associated with both short and long-term health consequences, depending on how much total radiation astronauts experience and the time frame in which they experience that exposure. Increased risk of cancer and degenerative diseases, such as heart disease and cataracts, have been observed in human populations exposed to radiation on Earth. Health risks for astronauts from radiation exposure in space are mainly driven by long-term impacts. Additionally, animal and cellular research indicate that the type of radiation in the space environment has a larger impact on health outcomes compared to the radiation experienced on Earth. Not only will astronauts be exposed to more radiation in space than on Earth, but the radiation they are exposed to could pose increased risks. ESA, European Space Agency. Samantha Cristoforetti replaces centrifuge components inside the Columbus Laboratory Module's BioLab, a research facility that studies the effects of space and radiation on microorganisms. Credit NASA, the key. The current strategy to reduce the health risks of space radiation exposure is to implement shielding, radiation monitoring, and specific operational procedures. Compared to typical 6-month space station missions, later Moon and Mars missions will be much longer on average. Consequently, the total amount of radiation experienced and associated health risks may increase. NASA is developing new radiation detectors to monitor and characterize the radiation environment, which will provide better estimates of the dose and type of radiation to which the crews are exposed. Scientists and engineers are optimizing and implementing operational procedures that use available vehicle stowage and materials to reduce radiation exposure effectively, to investigate the health risks of space radiation exposure beyond low Earth orbit. NASA supports research that analyzes the biological effects of simulated cosmic rays at ground-based research facilities. Research at these facilities helps NASA understand and reduce the risk of space radiation, ensure proper measurement of the doses that astronauts receive on the space station and in future spacecraft, and develop advanced materials that improve radiation shielding for future missions. Studies of radiation-exposed human cohorts are also being conducted to estimate the health risks in populations relevant to astronauts. NASA astronaut Scott Kelly, who spent 1 year aboard the International Space Station, is seen confined inside a Soyuz simulator at the Gagarin Cosmonaut Training Center. Credit NASA.